Right, this is a video for my Math 8 students working through Chapter 11 on probability. It'll be a pretty short chapter, particularly because we covered some probability back in grade 7. So this is just using a little bit of a different technique to expand on what you did in grade 7 already. So quick reminder of probability. Probability is simply the likelihood or the chance of a specific event occurring. In grade 8, we're going to limit our discussion to probabilities of independent events. So independent means the events do not depend on one another. So if independent things do not depend on each other, we could think of some examples perhaps. So example would be if I am going to toss a coin. There's two outcomes. I could get heads or tails, and then if I rolled a dice, roll the die, there would be, if it's a typical six-sided dice, there would be 6 different options for that. It doesn't make a difference if I throw a heads first. That doesn't change the probability at all of getting any of the numbers on the die. They are independent of each other. One does not determine anything about the other event. So we're going to limit our things to only talking about independent events such as those. So continuing on that example, if we used tossing a coin, sorry, a little messy, and rolling a die, what would be all of the different possibilities for those things if we did both of those things? There'd be 2 different ways that we can represent that. We're trying to list all of the possibilities. All of the possibilities is called the sample space. Okay, so you could start listing them all, but sometimes if you don't use a good systematic method, it's a little tricky to get it right. So we're going to use a systematic method called a tree diagram. Tree diagram, very simply, looks like a tree. So the first event would be I could get either a heads or a tails. Those are the 2 options. If I got a heads, I would have 6 options. See the little branches form? Yeah, I could have a 1, 2, 3, 4, 5, or 6. Okay, and likewise, if I got the tail, I could have the 6 different options as well. 2, 3, 4, 5, 6. So if I followed this through, I could see that there are all of these different options. So the first one would be a heads and a 1, heads and a 2, heads and a 3, etc. Okay, that'd be one way. That's called a tree diagram. Okay. Another way would be by using a table. Okay, so a table simply is a table, and on the top, the top you would have listed the possibilities for one event, and the bottom, or along the other side, you would have listed the possibilities of the other event. So 1, 2, 3, 4, 5, and 6. Okay, so then we just fill in the chart. So we'd look at this one could be a heads and a 1, this would be a heads and a 2, heads and a 3, heads and a 4, heads and a 5, heads and a 6. So you would just follow down this first column first and go down all the way to that column, and then you'd get to the second one and you'd do the same thing. Okay, just matching up both ends. That is called using a table to record the sample space. Okay, so both options work. You can have your preference on what you'd like to use. Okay, now we're not usually just concerned about the sample space. We're usually we're aiming to determine what the probability is. Now, probability has a formula that we use, and really it makes sense. Probability of an event happening would be the number of favorable results. Number of favorable results, and we divide that by the number of total outcomes. Okay, or the sample space, the number in the sample space. Okay, so back to our previous example, if we had flipping a coin and tossing a dice, we had, if we went back to it, we would see that we would have 12 total outcomes. Okay, so probability is 12 on the bottom is the number of total outcomes, and say we are looking for the probability of getting a heads and a 6. Okay, if we went through and we counted out, there would only be one spot, right? We could go back. There's only one spot, I said a heads and a 6, on the entire table that would satisfy that. So the spot that satisfies it is called a favorable result, and we put a 1 there. So the probability of that happening would be a 1 out of 12. Now, this is nice. You could do that, but it takes a little bit of time to generate those charts. So we're going to show you, this is where we're a little bit different than in grade 7. We're going to show you a way to determine probability of independent events a little bit more quickly. Okay, what was the probability of only getting heads? 1 out of 2, right? You got heads or tails. What is the probability of rolling a 6? 1 out of 6. Okay, how can we combine these two to get the same answer as that? Well, what if we multiplied them? Okay. Probability of heads and a 6 is equal to the probability of a heads times the probability of a 6. Okay, which means half times 1 over 6 will give us, you multiply the numerators first and then the denominators, gives us 1/12. There you go. Okay, we'll do one more example quickly. Okay, we've got a probability that, or a spinner with equal size portions. Okay, we're going to spin that spinner, and then we're also going to roll a 6-sided dice. Okay, and we want to determine the probability of spinning a B and getting a 3. Okay, that probability would be the probability of spinning a B multiplied by the probability of rolling a 3, which means what's the probability of spinning a B? It's 1 out of 3. What's the probability of rolling a 3? It's 1 out of 6. There we go. We've got 1 over 18 is the probability. And that, in a nutshell, is your probability unit. Okay? Pretty straightforward. You can now probably work through the review and wrap up this unit.
Made with Doodlecast Pro.